just so that other people that are not here can have it. So we're going to start talking, first of all, about exponent rules basics. And the basics are kind of going through each category. Like I said, you have videos that go in a little bit more detail, but I wanted you to have in one spot where you could look at and see all your rules, right? So first of all, right here, I've got x to the n. I want you to recognize that what is up high here is your exponent and this is your base. And a lot of people go, yeah, we know that, but I just wanted you to have that. So the first category we're going to talk about are same bases. So here is multiplication. I have x to the 5th times x squared. Now, most of you are going to say, well, I know all this already, and that's good. So if I have the same base, okay, and I multiply the same bases, I add my exponents. So this is going to be x to the 7th. So a lot of you are very comfortable with that, and that's great. So I know that if I have the same base, and I'm multiplying the same base, I'm going to add my exponents, okay? So that's for multiplication. Now for division. So here's division. I'm using the same thing, x to the 5th divided by x squared. So if I'm dividing and I have the same base, I'm going to subtract my exponents. So this is going to be x cubed, all right? So if I'm dividing and I have the same base, then I'm going to subtract my exponents. Now, a lot of you have been doing this since middle school, I know, but I just want to make sure that we're comfortable with this, all right? So there's our basic for that. Now, the next thing we talk about is negative exponents. Okay, so underneath negative exponents, I put in parentheses upstairs / downstairs. So for negative exponents, and a lot of these, what I'm going to have you do in this lab, some of the exponents come out to be negative, which is fine, but they'll want you to write it with positive exponents. So here's an example. If I had x to the negative 5, all right, if I wanted to write that with a positive, if you think of this as over 1, you can actually bring it down and write it like this, 1 over x to the 5th. So now it's written with a positive exponent. Okay, so that one, I know some of you have probably seen before, but you haven't done it in a while, and I wanted to make sure that you're comfortable with that. You also could have something like this, 1 over x to the negative 5. And if you have it like that and you want to make it positive, you can actually bring it up, and that's actually an x to the 5th. So it works both ways. Wherever you're negative, you can move it upstairs or downstairs as long as they're factors and make it a positive exponent. So there is a little update on negative exponents. The next category we do is power to the power. And I kind of write it like this, big power to the power. Now, powers are another word of exponents. So what you're going to do is multiply the powers. And I put that in parentheses because they're exponents. So on this one right here, if I had something like this, x to the 5th, and I'm squaring it, so I have basically an exponent raised to another exponent, or power to the power. You could write this like this, x to the 5th times x to the 5th, because that's what it says. It says, hey, I want you to write 2 of them, and then because they have the same base, I add them, I get x to the 10th, which is all well and good, but you really don't need to show this part, that if I know the rules power to the power, all I have to do is multiply those and get x to the 10th, right? It works this way as well. If I said x squared raised to the 5th power, that's basically writing x squared 5 times, but if I multiplied those 2, I would get x to the 10th. Okay? Now there's one that I wanted to show you over here, is you could have this, x to the negative 2 raised to the positive 5. So if I have a negative exponent here, just making that look a little nicer, sorry. When I multiply these power to the power, I get x to the negative 10. And because this is a negative exponent and I want you guys to write it with positive, I'm going to bring it down. That's 1 over x to the 10th. So that's kind of what I'm talking about on this lab, is you're going to do work, but you're going to do several steps to get it to the answer. That's why it doesn't always, something like this, I could do and write it like this, but some of these other ones you're going to have to move around. So there's power to the power. So you're going to multiply your powers or your exponents to come up with your answer. Right? The last, well, next to the last category, I should say, is rational or fractional exponents. And underneath that, I wrote flower power. So my mother's an artist. I'm not. I'll be the first person to tell you that. So I'm going to write a big fraction, 2/5, really nice and big. Right next to this, I'm going to draw a flower in a flower pot. So here's my flower pot, okay? And then here's my flower. So here's the stem, all this stuff. I know I'm not a good artist. So I'm going to make it a blue flower. Maybe some purple here. It doesn't really matter. Okay, so here's my flower. So I kind of learned this in college, that whatever's next to the 2 is a flower. So this is a flower. So that means my 2 is a power. Okay? In my flower pot, my flower has some roots. So right next to the flower pot is the 5. The 5 is my root. So if I had x to the 2/5, I want you to think of that. It's a fractional exponent. It's less than 1. Is to look at the like a little flower pot. So the 2 would be the power because it's flower power. The 5 would be a root. So basically I kind of just made it big over here, but really that's what it is. So you can write it with a radical. You can rewrite it. So the x is going to go here, the power goes here, and the root will come out here. So I used to memorize this. And when my professor, he had a big flower power poster in his college classroom, that this like made so much sense to me. So I always knew when it was fractional, I could rewrite it as a radical. So if I could give you this in red means the same as this in green, means the exact same thing. Okay, that's fractional exponents. The next one I want to talk about is zero exponents. So let me just put this up here in case you're trying to still copy it down. And again, I'm recording this so you could look back and redo this if you wanted to, is zero exponents. So basically anything raised to the 0, I don't care what it is. So I'm going to make up a number raised to the 0. It doesn't matter what you raise to the 0 power, okay? It's always going to be a 1, always. Okay? It doesn't matter what's in the parentheses, but it does matter how it's written. So for example, if I had 3x to the 5th, all raised to the 0 power, I see this whole thing is raised to the 0 power. And really, there's a little 1 here, but when you do flower power, this makes it 0, but the whole thing is 0. It's 1. Okay, so you're like, okay, I get it. But watch if I write it like this. If I write it like that, where I only put the parentheses and raised to the 0 power, as you can see, the only thing raised to the 0 power is that x to the 5th. So this is the same as saying 3 times 1 or 3. Okay? So you have to be careful what is being raised to the 0 power. The other way you could write it is like this. So that's going to be 1 times x to the 5th equals x to the 5th. And I'm just showing you that because lots of times people go, oh, it's 1. Well, it is 1, whatever that part that's being raised to the 0 power. All right, and I have one more thing I want to show you on this. So I'm going to extend the page here. So before I said if you have the same base, you can combine your exponents by adding them if you're multiplying the bases and subtracting them if you're dividing the bases. But there is something where you have exponents are the same The exponents are the same, but your bases are different. And all of you kind of know this, but you kind of don't think of it. So that's why I wanted to show you. So I always tell the kids in calculus, you can only combine exponential functions if two things happen. One, the bases are the same, or the exponents are the same. All right? So let me give you an example of this. If I had 2/5, okay, raised to the third power, all of you would say, oh, that's power to the power. These are little ones. I'm just going to multiply. So that's the same as 2/3 divided by 5/3. Okay? So basically, 2/5 raised to the third power is the same as 2 to the third over 5 to the third. Or you could see it like this. I could tell you 2 cubed over 5 cubed is the same as saying 2/5 cubed. So most people are pretty good this way, saying, oh, I know how to rewrite that. I'm just going to multiply power to the power and rewrite it without the parentheses. But when they get it this way, when it's 2 cubed over 5 cubed, they kind of forget it's the same as saying 2/5 cubed. So I kind of wanted to show you that because that is the one that people are like, yeah, I kind of knew that, but it's more uncomfortable for you because you haven't done as much. So basically, those are kind of the rules that you're going to see in all those videos to a lot deeper degree. So make sure you watch those 3 videos and take your notes in your spiral notebook. So now I'm going to go and start working on the lab. So what I did was had people unmute and kind of tell me which ones they wanted me to do. But I'm going to start out here on the Exponent Practice Lab. So this is in your packet on page 14. On page 14 and 15. There's 31 questions. I'm not going to do a lot of these at the very beginning because they're much easier. I'm going to start doing the more difficult ones. So I'm going to start at the second row. Okay, and I'm going to do a few with you, and then I'm going to kind of let you unmute and tell me which ones you want me to do. So here's this row. First of all, this very first one is very simple because I see the whole thing is raised to the 0 power. This is a 1. There's really no work to do with that. That's what it is. But things like 6 kind of bother people a little bit. So I want to kind of do something like 6 with you. So the first thing you want to do is get rid of these parentheses. So I have a -1 and a -1 here. So basically I'm going to do power to the power. But most people are pretty good. Excuse me, not -1, a 1. I'm so sorry. Forget I just said that, a 1 and a 1. But what people are kind of confused about is that they forget to do the numbers. They're pretty good with the X's and Y's. And the other thing I want you to recognize, these are all factors so that you're able to do this. So I have 1 times -4 is 2 to the -4, X to the -4, and it's like a little 1 there. So that's X to the -4, all over 3 to the -4, Y to the -4. Now that's correct. But now I want you to write it with all positive exponents. So you can like move them around where they're positive. And since these are all negative, I'm going to just do a lot of upstairs, downstairs. I'm going to move this down here, move that up there, and vice versa. So now I have 3 to the +4 over 2 to the +4, y to the +4 over x to the +4. And then I'm just going to put the 3 to the 4th over 2 to the 4th in my calculator, and it will simplify it. This comes to be 81 y to the 4th all over 16 x to the 4th. All right, so that's the answer to that. So this is what I'm telling you. A lot of these you need to show the steps before you come up with it, because this whole lab, if you were to look at the top, okay, right here, I only want positive exponents. So if you get any negatives, you got to make them positive. All right. Now I want to show you something cool on this as well. So I'm going to do 6 another way. So just watch me here. I just want to show you this because there's more than one way to do a lot of these. So because this is raised to the -4, you can actually just flip the fraction on the inside and write it like this way: 3y over 2x all raised to the +4. Because really, if you did this, it's negative. You could do 1 over this, and then when you do 1 divided by a fraction, you can flip it. So that's the same thing. And when I do that, I got 3 to the 4th, y to the 4th. See how there's no negatives? 2 to the 4th, x to the 4th. And do you see how that's the same and you're going to end up with the same answer? So that is pretty cool too, is that if you have something raised to the -4 power, you can just flip the inside, don't change any of the signs or anything, and then just do it from there. They're both the same. Okay? Number 8 caused a little bit of questions for people. They're like, Mrs. Pond, how do I do that? So if you look at these, I have a parentheses, 3x squared. So I'm going to write it without it because it's really 3 times x squared. Here, I'm raising the 4. It's to the first power, 1 times that. So that's going to be 4 to the 5th. So you're multiplying it by this times x to the 5th. So basically, you're now going to multiply your numbers. And if you do 3 times 4 to the 5th, you get a huge number. You get, oops, sorry, 30, let me see now, when I multiply that, yeah, 3072 x to the 7th. Okay, so that's how you do 8. On this one, I think you'll be pretty good. Is there anyone that would like me to do one? Just unmute and tell me a number. Pick one, guys. Somebody pick one and I'll do it. Which one, hon? 11? Sure. So when I do this one right here for 11, this is 3 to the 1st. I kind of remember that. Now, there's, like I said, there's more than one way to do these. I'm just going to kind of move them around and make them all positive. Okay? So if I did that, I'm going to move the 3 to the -2 up here. So I have 3 squared times 3 to the 1st. Then I have an x squared down here. I'm going to move this down there and times x cubed. So when I have the same bases, I'm going to add the exponents. So I have basically for 11, I have 3 cubed over x to the 5th, and 3 cubed is 27 over x to the 5th. Okay, that's one way to do that. So I'm going to show you another way in a second. Okay, you could do 11 this way. So a lot of people like to do it this way. They go, Mrs. Pond, you have same bases, so I'm going to do what you said. So this is a 1. So if I have the same base, I can subtract my exponents. So if I have a 1 minus a -2, that's 1 plus 2, that's 3 cubed. So they get that right off the bat. And then they do x, these bases are the same. I have -3 minus 2, so that's x to the -5. And then they go, okay, this is over 1. I can bring this down. So you still end up with 27 over x to the 5th. Either way works. As long as you remember, because a lot of times when people are subtracting the exponents, they go, well, where do I put it? I said, always put it in the numerator, then move it later. Okay? Good question. All right, so everybody get ready. I want you to pick one from each row. I'll do one from each row, and then I'll stop. So which one on this one looks the worst that you would like to have me do? Unmute and just give me a number. 15, perfect. Okay, so 15 looks kind of ugly. Mrs. Pond said get rid of the parentheses first. This 2 is raised to the first power. That's raised to the first power. So I'm just going to do power to the power. Or I can flip it. But let's just leave it because a lot of times when people flip it, they're not for sure if they change anything. But you can do that as well. So I have 2 to the -2 because 1 times -2. A to the -2 times -2 is a +4 all over 3. 1 times -2 is -2. B, 3 times -2 is b to the -6. Now, I'm going to make things positive. So the 8 to the 4th is going to stay up there. I'm going to move this up and make this b to the 6. Okay? Now I look at it and say, okay, I'm going to move this up here, move this down here, make that 3 squared and 2 squared. So I end up with 9 a to the 4th, b to the 6, all over 4. Or you can say 9/4, a to the 4th, b to the 6th. But this is perfectly fine. This is perfectly fine. Okay? All right, I'm going to go to the next row. Okay. Unmute, pick one, guys. Oh, 20. Did I skip a row? Yes, I did. Thank you for that, hon. I skipped 2 rows. Oh, my goodness. Okay, ready? So let's do this one right here. 20, same base. If you want to put a 1 in front of that A, you can. If I have the same base, you're going to subtract. So X, if I have 3 A's and take away an A or subtract an A, it's 2A. Okay. And then I'm going to take my Y's. I have 4B's minus a negative 2B. So that's going to be 4B plus 2B. So that's Y to the 6B. And they're both positive. So we're good. We don't have to do anything with that. Good question. That one, see, that one didn't have a lot of work with it. Sometimes they have that. How about this row with a 21 through it? Pick a number. 24. Good one. This one, first block, pick this one too. So if you look at this one right here, I have the numbers 18 over 45. So if I put that in my calculator or say, you know what, 9 goes into both of those. 9 goes into 18 twice. 9 goes into 45 5 times. That reduces down to 2/5. Or you can put that in your calculator. Okay. Now the U's, all right, just to remind you, whoops, the U's are the same base. So I just because I have a binomial, still you're going to do the same thing. You're going to subtract this minus this. But you leave it in the numerator and say, okay, I have 3 S's minus 1 S. That's 2 S's. That's an S, not a 5. Then I have negative 2 minus negative 2t minus t. That's minus 3t. So you could write it as 2/5 u to the 2s minus 3t because it's a binomial, or you can leave it as 2 u raised to the 2s minus 3t. Both of those are fine. It's easier than it looks because you're just subtracting basically this binomial minus this binomial. Good question. Okay. Next line. I'll do one of them with you. 26. Okay. 26 is a good one. Because when you do 26, I'm going to kind of do it the way it is. And I want to show you guys how this negative 2 raised to the third power is different than 2 raised to the negative 3. First of all, you're not going to do upstairs, downstairs with that because the 2 is negative. So basically, when I do that one, I said, well, negative 2 cubed is a negative 8. It's actually a negative 8. The exponent is positive. It's a 1 if you were thinking about it. And so I have an 8 down here. I'm going to go really slow. So I'm going to leave it there. I do know that reduces to negative 1, but I'm taking my time. So now if I do these, you can move them around, or I can say negative 4 minus 3 because these bases are the same. I have x to the negative 7. If I have negative y to the negative 2 minus y to the negative 1, it turns to a plus 1. I have y to the negative 1. So negative 2 plus 1 is negative 1. Now I'm going to continue on. Like I said, there's more steps to this. Because this right here is a negative 1, I know this whole fraction's negative, but I'm just going to put the negative 1 here. And then I'm going to move the x to the 7th to make it positive downstairs. And I'm going to move the y to the downstairs. So that's what that comes out to be. It's negative 1 over x to the 7th y. And it's because this entire lab is positive exponents and making you move them around. Good one. Thank you for that one. And I think I have one more line here to do. Pick one, and then I'll let you work on this. $30. Okay, 30 is a good one too. So basically here you want to get rid of the parentheses. So I'm going to do power to the power. So I have x to the 9th, 3 times 3, all over y to the 6th, And then I'm exaggerating how big this is to show you that it's still a fraction over a fraction. And so this is going to be x to the negative 4 all over y to the negative 2. Now, the reason why I did that in different colors is because if I have a fraction divided by a fraction, you guys learned a long time ago, it's the same thing as doing this. X to the 9th, y to the 6th, times the second fraction, the reciprocal. You're flipping it, okay? Now, I look at it and say, okay, that's nice, but I've got some negatives going on. Well, you can move them up and downstairs if you want. You could actually flip this fraction and make it positive, or you can subtract where it is. But let's do that. We'll say that's x to the 9th, y to the 6th, times, and I'm moving this and up down here, x to the 4th over y squared. I made them positive. There's more than one way to do this, guys. And now I have the same base, I can add them. So I have x to the 13, same base, I can add them, y to the 8th. Other ways to do that, but that's one of the ways to do that. So I'm going to stop presenting and stop recording. So give me 2 seconds to do all that, please. So first of all, I'm going to stop recording.